Hi everyone, this is Professor H. Rahman. I welcome you to the lecture 2 of Traction Engineering course, where I will try to cover the classification of wheels, forces and moments acting on the wheel. The concepts which will be covered will be difference between a rigid wheel and flexible wheel, forces which are acting on braked, towed, self-propelled and powered wheels, then forces and moments acting on a wheel. When we talk about wheels, wheels could be a rigid wheel, wheels could be pneumatic wheel. Again, pneumatic wheel can be divided into two types: rigid wheel, a rigid mode of operation and flexible mode of operation. When I said rigid mode of operation, that means the ground pressure is not sufficient, the ground is not sufficiently strength, ground doesn't have sufficient strength to support the wheel. So as a result, the wheel will sink and it will behave like a rigid wheel. When the ground has sufficient strength, it will try to deflect the wheel, so it will be in a flexible mode of operation. So sometimes the pneumatic wheel behaves like a rigid wheel, just like your cage wheel. Initially, so what happened? No, the steel wheels are used or are fitted with tractors, but the limitations are it cannot run on the paved road. The ride is extremely tough in the sense there will be good amount of vibrations and there will be high soil compaction. So in 1934, the first tractor which came with a pneumatic tire, that is W.C. Alice Kalmars, who tested this tractor when fitted with rubber tires at Nebraska Tractor Testing Laboratory in UK. In early 1930s, companies began to offer pneumatic tires on farm tractor. Nowadays, almost all tractors are provided with pneumatic wheels or the rubber tires. Then the other traction element which is used is your trucks. Trucks could be again rubber trucks, it could be metallic trucks. So now coming to the wheel can be classified as powered wheel, it can be classified as towed wheel, it can be classified as braked wheel, or it can be classified as self-propelled wheel. So these classifications are based on power and torque characteristics of the tire versus slip. Now, what is a powered wheel? When a wheel is provided with a torque, that means initiated with a torque, then it is powered. But now if you look at the wheel versus the torque and pull characteristics of a rubber wheel, I have indicated here. This is the torque, this is the pull, and torque is touching the x-axis at this point, where pull is touching the x-axis at this point. Origin is this point. Now first we look at this point where the pull is 0, but still some torque is acting, okay, and that condition is called self-propelled condition. What do you mean by this self-propelled condition? Self-propelled condition means the thrust which is developed because of the interaction, because of the supply of input power or input torque, that is sufficient to develop a tractive force which will overcome the rolling resistance. There is no pull. So pull is 0, which is indicated H as 0. Now this point refers to self-propelled condition. The best example of self-propelled condition is, or self-propelled wheel is your cars, the bus, tires of the buses, trucks, etc. So these are the best example of self-propelled condition. Now, in self-propelled condition, T is greater than 0. That means torque has certain value. It has a weight W. Then this is the tractive force which is developed, and G is the Sol reaction. Look at the orientation of Sol reaction. So it is towards the contact patch and it is vertical. Now the other condition which I will indicate is this point where torque is equal to 0. When torque is equal to 0 means that condition refers to towed wheel. Towed wheel means there is no torque, only weight is acting, and the Sol reaction, look at the orientation of Sol reaction. This is no more vertical like this is inclined and it is passing through the center line of the wheel, and this towing force, this is the force required to roll the wheel. So here there is no torque, T is equal to 0. So this condition is represented by the point here, and the difference between this point to this point, so this is the towing force. That means this much force is required to roll the wheel forward. I am talking about these forces on a horizontal plane. If the plane is inclined, then a weight component will come into picture. Now, the third wheel which we will be talking about is your braked wheel. If you look at this figure, brake wheel, the torque applied is just opposite to the direction of motion. Just like in case of self-propelled wheel, the torque is applied in clockwise direction and the wheel is moving forward. But here the torque is applied in the opposite direction, okay, and weight is applied, and look at the Sol reaction. It is still inclined more than the Sol reaction which is obtained in case of towed wheel. And there is a thrust, there is a pull H, pull is there, okay. So torque is less than 0. So this is called brake wheel. The best example of brake wheel is your ground wheel of a seed drill. The best example of towed wheel is the wheels which are provided in a bullock cart. Now the fourth wheel is your powered wheel. In case of powered wheel, torque is applied, so torque is greater than 0. There will be weight and pull is applied, and the Sol reaction will be inclined in the opposite direction to that which we can see in case of a braked wheel or in case of a towed wheel. So because of the torque application, there will be interaction of this wheel with soil, and the force which is developed, that is tractive force, that will take care of this pull H and the rolling resistance, okay. So if you look at these four wheels, what are the forces which are acting on these wheels, and how the ground reaction is behaving, how it is orienting towards the left side or towards the right side, that is very clear from this figure. So that's why I have indicated that any wheels coming towards this side will be called as driving wheel. Any wheels coming towards the left side from this line will be braked wheel, and the border lines will be your self-propelled wheel, and in this side this will be your towed wheel. Now, based on construction, the pneumatic wheels can be called as bias tire or bias belted tire or radial tire. Commonly, the bias ply tires are being used by the tractor manufacturers, either bias tire or bias belted tire. And nowadays, radial tires are coming into picture. The only advantage in case of radial tire is it will have more sideward deflection. So contact area is more. That is the main advantage over belted or bias belted tire. Then the difference between bias tire and the bias belted tire is, in case of a bias tire, there is no belt provided below the carcass, whereas in case of a bias belted tire, there is a belt provided which will provide more stiffness, or which will give more stiffness to the tire, so deflection of tire is reduced. Whereas in case of a radial tire, there will be a belt. Okay. So these are the basic differences, and we will cover in detail the tire construction in my subsequent classes, where I am going to take the little bit about tire construction. Now the next important thing is what are the forces of the moments acting and how do you represent it? That is important. So to describe the forces and moments acting on a wheel, we have to take the help of a axis system which has been recommended by Society of Automotive Engineers, where there will be three forces, three moments, and this will be indicated in this figure, which you can see on the right side. Then first we have to define the x-axis. The x-axis is nothing but the intersection of the wheel plane with the ground plane. Okay. Then y-axis is perpendicular to the ground plane, perpendicular to the x-axis, and the z-axis, the y-axis is your ground plane itself, and the z-axis is perpendicular to the ground plane, and the positive directions are x-axis, the positive direction is indicated here, that means moving forward, and z-axis the positive direction is downward, and y-axis the positive direction is towards the right side, so that the entire axis systems become orthogonal and a right hand type. The next thing is, what are the moments acting? There are moments about x-axis, there are moments about y-axis, there are moments about z-axis. So the moment about x-axis is called the overturning moment. The moment about y-axis is called the rolling resistance moment, and the moment about z-axis is called aligning torque. So when the wheel is moving in any soil, so there will be soil reaction coming from the ground to the wheel. So when you resolve this soil reaction into longitudinal direction, that becomes your x-axis. When you resolve that reaction force which is coming from the ground to the wheel in the x direction, that becomes your longitudinal force. We call it longitudinal force. And if when it is resolved in the y-axis, that is called lateral force. When it is resolved in z-axis, about z-axis, that is called normal force. So these are the three forces which are coming from the ground reaction which is acting on the wheel. Now, in addition to these three forces and three moments, there are two angles indicated here. One is slip angle alpha, the other one is camber angle, positive camber angle gamma. This slip angle is nothing but the angle between the direction of travel of the wheel and the intersection of wheel plane with ground plane. So this angle is called slip angle. And camber angle is the angle which the wheel plane is making with the xz plane. So these two angles are important because they will be responsible for developing the cornering forces and the steering as well as the cornering forces. When we will try to cover there, we will discuss what is its effect and how it is to be controlled. So, in summary, you can say there will be three forces acting, three moments acting, and this is the axis system which has been prescribed by Society of Automotive Engineers to mention or to define different performance parameters. So, we can conclude that in this lecture we try to discuss about the classification of wheels based on pull, based on torque, and then we try to define the moments and the forces which are acting and the two important angles which are associated with the wheel. Thank you.